My final project is on Splunk Storm. First off, what is Splunk Storm? Splunk Storm provides a real-time and historical snapshot of your cloud applications in all server environments by collecting and organizing all event details under one umbrella. One of the great things about it is that it is elastic and scales to your needs as your data grows. You pay only based on data used, hardware is not your concern, and it is platform independent. That is, it does not care what the structure of your data is, it just digests it and organizes it to make it readable and useful. This product is not to be confused with Splunk Enterprise. Enterprise is similar, but is designed to be managed by your organization and stays inside of the network. Enterprise has fixed licensing and is currently much more robust when it comes to application development and its software API. Storm is the new platform that Splunk is developing. My impression is that Storm will handle most of Enterprise's features in the future. Let's take a look at 3 use cases for Storm. One of the great things that Storm does is helps you keep your finger on the pulse of your environment. Gone are the days of reactionary troubleshooting and long downtime spent determining your problem. You can now discover that a problem is happening much sooner and really get quick details about what the root cause is. You can use Splunk Storm to filter logs by time or by conditional searches to troubleshoot issues. Let's say that you run a website that sells flowers, and that you are sending Apache logs and MySQL logs to Splunk Storm. You receive a call from a customer when he keeps receiving a server error when he tries to complete a purchase. Everything is searchable in Storm. So you get his IP address, and you enter 10.2.1.44 into the search bar. Hit enter, and now you are looking at all of this customer's traffic to your online store. Any of the events associated with this IP address have been logged from your application to Storm. So you see a lot of 200 response codes, but you are only interested in errors, so you filter out any event that is not a 200 success response. And now you have a smaller list of events. Notice that each of the events appears in the timeline below the search bar, and double-clicking on the bar reruns the search over a smaller time range. So if you drill down a bit, you can get to the 1 minute window which one of the events occurred. Knowing the time window of one of the errors, you broaden the search to include everything that was happening in the application around the same time. And you get a bunch of database errors. This is a pretty good indicator of the root cause of the error the customer is seeing. You can also use Splunk Storm to monitor system usage, uptime, and any other operational metrics to help you run your application. Let's say that you want to make sure that you know immediately if there are any failures at purchase time in your online store. You want to display a dashboard on a screen in your office. So you build a search that returns user IP addresses sorted by the number of failures they saw at the time they were trying to complete a purchase from your application. The search is here in the search bar, and in the results you can see that one IP address failed a number of times. You can easily save and visualize this search on a dashboard to be able to quickly rerun the search and answer this question anytime. In the Create menu, choose Dashboard Panel, give it a name, create a new dashboard, and choose a visualization that helps communicate the results. Now from anywhere in Storm you can click Dashboards and Views to navigate to your list of top fails by IP address. Hopefully you would rarely see purchase fails, but if you do, you can quickly troubleshoot, reach out to customers, fix bugs, add capacity, etc. Any search you create can be added as a panel on a dashboard. That is how you can easily visualize a specific set of metrics that apply to your application's needs. Another use case is to measure and explore the success of your applications. Let's say that you want to determine who the customers are who have purchased the most flowers and how many flowers each has purchased. In my example dataset, there are key value pairs for user actions and product categories. So I search action equals purchase, category ID equals flowers. This returns all of the events that represent discrete flower purchases. But when you look at it, you see there is no way that you could say by looking at them which IP has purchased the most and how many they purchased. So I need to organize the data so that the top purchases are obvious. I'll use the pipe operator to feed all of the flower purchases into the stats count command. I'm going to group by client IP. And finally feed those results into the sort command. I'll sort by count and add a minus to sort descending. As you can see, we found all flower purchase actions, grouped them by IP address, and sorted them by purchase count. Some of you may be wondering how the data gets into the environment. Splunk uses the REST API to port their data. However, most common imports can happen through the Storm GUI by manually uploading files, direct server uploads, or network forwarding. To set up the server uploads is really quite simple. It requires you to authorize your IP address, and then you configure your data source to point to Storm. Storm uses an access token and project ID to decrypt the data. To perform network forwarding, you put a system in the middle that sits on your network and manages all of the data that is forwarded to Storm. The Storm GUI also allows you to manually import data by just uploading it to the system. This is the easiest way to get the data in, but in a real-world scenario it is not reasonable. From an archival, this is when you first start using the application in your environment, but this is not appropriate for real-time analytics. If none of these options suit your situation, you have to use the REST API. The usage is a bit limited at this point. It only accepts Ruby and Python scripts. There is a one-line entry option that allows you to potentially manually script anything to be added to the environment, but at this point a lot of work is on you. Here is a Python script that imports data from your server to the Storm environment. Splunk was nice enough to dynamically create the exact file that you need for your configuration. I did have to install a package management app called Nix to get it to work. And this screen shows the command to import by file name using REST. I show more details of how REST performs an import in my documentation if you're interested. So in conclusion, Storm is an exciting new concept that allows you to organize, monitor, and manage your network environment. It has a simple front end and has a brighter future as development is still actively happening. Who knows where this application will end up?